Today, we are diving deep into one of the most fundamental conflicts in all of software. It's a debate that really shapes how we build things, what we can even imagine building. And it all comes down to a deceptively simple question. How should we represent our data? You know, the philosopher Ludwig Wittgenstein once said, "The limits of my language mean the limits of my world." And that is exactly the case with data. The data models we pick, they're a kind of language. They define what we can say, the questions we can ask, and ultimately, the limits of that data model become the limits of our application's entire world. So how do we get from messy, everyday reality all the way down to electrical currents on a chip? Well, it's not one giant leap. It happens in layers. We start with the real world, we model it in our applications with objects and data structures, and then, and this is the crucial part, we have to translate that model into a general-purpose data model. That third layer right there, the one with tables, documents, and graphs, that's the battlefield. That's where the great data debate is happening right now. So let's start with the undisputed king of that middle layer for a very long time, the relational model. For decades, this was the answer. It was the way you brought structure and sanity to the chaos of business data. And when I say a very long time, I'm not kidding. We're talking about a reign of nearly 30 years. I mean, in the world of computing, that is an absolute eternity. This wasn't just some popular choice. It was the bedrock, the foundation that almost everything was built on. But as our applications got more complex, a really annoying point of friction started to show up. It's a problem called impedance mismatch. Just think of it as this awkward, clunky translation you're constantly forced to do. You've got these rich, beautiful objects in your code, and you have to smash them flat to fit into these rigid grids of tables and rows. It's just painful. And this right here shows the problem perfectly. Let's take a single LinkedIn profile. In the relational world, on the left, you have to literally shred it. You tear it apart into a user table, a positions table, an education table, and then you have to stitch them all back together with these IDs. But look at the right. In a document model, the profile just stays together. It's one self-contained logical thing. So all that friction, that impedance mismatch, it basically created an opening. It was time for a challenger to step into the ring. And that challenger was the document model, an idea really born out of the needs of a modern web-scale world. So what was the big appeal? Why did everyone get so excited about document databases? Well, for one, you got schema flexibility. That meant you could change the structure of your data without these massive, painful migrations. You also got better data locality. I mean, if the whole profile is in one place, fetching it is going to be way, way faster. But the big one? It was just so much closer to the objects we were already using in our code. That annoying impedance mismatch, it just kind of melted away. But hold on, the relational model wasn't going down without a fight. It had some serious advantages. For one, its ability to do joins, to effortlessly combine data from lots of different tables, is incredibly powerful. And that shredding we talked about, well, it has a purpose. It's called normalization. And by splitting data up, you guarantee consistency. You only have to update a company's name in one single spot. Plus, you know, it's a technology that's been battle-tested and optimized for decades. But here's where the story gets really interesting. This whole debate, this new fight between self-contained documents on one side and interconnected tables on the other, it's not new at all. In fact, it's almost a perfect replay of a database war that was fought way back in the 1970s. Okay, this is the big aha moment. On the left, you've got IBM's IMS database from the 70s. It used a hierarchical tree-like model. Now look at the right, today's document databases. The similarity is just stunning. Both are amazing for one-to-many relationships, right? One user profile has many jobs. Perfect. But both models start to get a little clumsy when the data gets super interconnected. You know, many-to-many relationships. Think a student in many classes and a class with many students. This whole history lesson isn't just about how data is structured. It actually sets the stage perfectly for the other half of this whole debate. It's not just how we store the data, it's how we query it. How do we ask it questions? And on this point, the differences are huge. And this really gets to the heart of what made SQL such a revolution. On the left, older systems were imperative. You told the database how to get what you want. You wrote the step-by-step recipe. But on the right is the declarative approach that SQL pioneered. You just describe what you want. You show the database a picture of the final result, and you let its super smart query optimizer figure out the best and fastest recipe to get it for you.
And if you've ever touched web development, this analogy will make it click instantly. On the left, declarative CSS. You just state a pattern. Make the paragraph inside the selected list item blue. It's simple, it's elegant. Now look at the right. That's the imperative JavaScript to do the exact same thing. It's clunky, it's longer, and it's way harder to see what's going on at a glance. SQL brought that CSS-style elegance to the world of data.
Okay, so we've covered neat tables, and we've covered self-contained documents. But what if your data doesn't really fit either of those molds? What if the most important thing about your data isn't the data itself, but the connections between everything? For that, we need a whole other way of thinking, the graph model.
This is the fundamental mind shift you have to make for graph databases. In a graph model, the relationships, the connections, the links, they aren't just some secondary detail. They are first-class citizens. In fact, you could argue that the relationships are the data.
And the building blocks are actually super simple. You have vertices or nodes, which are just the things, people, places, events, whatever. And then you have edges, which are the relationships that connect those things. That's it. The entire system is built and optimized for one thing: finding paths and discovering connections, lightning fast.
And if you're not convinced, this is the knockout punch. The task is simple. Find all the people who were born in the US and now live somewhere in Europe. On the left, in the graph query language cipher, it's 4 beautiful lines that basically draw a picture of the pattern you're looking for. On the right, the same exact question in SQL is a 29-line recursive nightmare. I mean, come on. It's the difference between describing a path and having to write a complex algorithm to find it.
So after all of this, who actually won the great data debate? Was it the relational model, the document model, the graph model? The answer is yes. It's all of them. And none of them. Because we've been asking the wrong question all along.
The modern way of thinking about this is something called polyglot persistence. It's a fancy name for a really simple, powerful idea. The search for one database to rule them all is over. Instead, modern applications use a mix of technologies, choosing the absolute best and most specialized tool for each specific job. So it all just comes down to knowing the trade-offs. The relational model, its key strength is joins and consistency, perfect for structured data. The document model, its strength is flexibility and locality, which makes it a dream for rapid development with self-contained data. And the graph model, well, its key strength is the relationships themselves, making it unbeatable for highly interconnected data. There's no single best answer. There's only the best tool for the job you have right in front of you. So I'll leave you with this question to think about. When you look at your own data, what is its true shape? Do you see a perfectly organized filing cabinet, like the relational model? Do you see a flexible, messy, self-contained scrapbook, like the document model? Or do you see a rich, tangled web of connections, like the graph model? If you can answer that question, you'll know exactly which language you need to be speaking.